Okay, we're rolling. This is Dave Morrison from Adatus.
Hi.
Or is it Adatus or Adatus? I never know.
I think it's Adatus.
Okay.
That's how come I think we have that.
Alright, cool. Alright, Dave, over to you.
Hi, so I'm Dave Morrison, BI consultant from Adatus. Just going to show you an extract from my talk script. It's going to look at ordering of columns in indexes. There's a kind of a common misconception that you should always have the most selective column as the first column in a multi-column index, and while that is true in a lot of cases, there is a rule that comes before that. So we'll have a look at that now.
Good stuff. Let's get into the code.
We'll look at the code. So what I've got here is a table I've created, just two columns, a gender column, so a chart one, so only ever going to be M and F, male and female, and then we've got an age, which is a tiny int. So a very unselective column and a quite selective column in age. So what I've done now, I've actually run all this already. It's kind of a blue Peter. Here's one I made earlier job. I've created a number table with 10 million rows in, and I've used that to do a random insert on the code. Basically, just if it's an odd number or if it's an even number randomly, then it's male and female, and then it just takes the last two characters plus one for the age. So it just inserts a bunch of rows in table. So there's 10 million and 1 rows in my SQLBits demo table now, with just random data in. So I'm going to do a DBC free prop cache and drop clean buffers just to prove that we're not cheating.
And why do you do that, Dave? Just for people that don't know.
So it empties out the plan cache and gets the stuff out of the buffer. So it's just you make sure you're not reusing something. Make sure you've not done cache warming and that kind of stuff.
So you're effectively restarting SQL Server by doing that.
Kind of, you're nuking out a lot of the stuff that kind of. It's good to do it on a production server because it stops SQL Server having to redo it.
Yep.
But in this instance, we're just doing this as an example, so we can sort of demonstrate that we're not cheating.
Yep.
So I'm going to turn my statistic IO on just to demonstrate the point. Now, the point of this example is that we're going to show that having a less selective column as the first column in a multi-column index is actually better under certain circumstances. So what we've got here, we're going to run this select statement with no index on it. There's no index on this table at the moment. Let me just put actual plans on. We're going to execute it. That's going to run for a couple of seconds. And there aren't any. That's good. There's no data in that table.
I knew. Back up.
Yeah, stuff is it. Okay, where's all that data got? Oh, I'm in the wrong chucking database, that's why. What a hero.
I love these ad hoc videos. I always catch people out.
There we go. There we are. Right, so there's some data in there. So that's going to run through. That's going to take a couple of seconds. We can see here what we're looking at is logical reads. So logical reads, in effect, is the amount of 8 kilobyte pages that you're reading from the table. Yep. So we've read, we'll copy that out just for example so we can see it's about 23,500 pages we've read there. So let's kind of here's one I made earlier. Different logical reads there because it was a different set of data. I'll just paste that in. Sorry, paste that in. Logical reads. So what I'm going to do now is I'm going to stick a clustered index on this table, and I'm going to put the age first and the gender second, and that's kind of traditional wisdom. You put the most selective column first, because there's only 2 values in gender. Yep. I'm going to execute that. That's going to take a couple of seconds to get to clustered index. It's just resorting the data on disk. There's 10 million rows in there, so we'll take a second or two. There we go, so that's done. I'm going to drop the free prop cache and drop clean buffers again to make sure we're not cheating. And then we're going to run the query again. As you'd expect, when it comes back, the number of logical reads has gone down by quite a lot. Yeah, the number's gone down. It's a big number. It's gone down. And that's great. That's an improvement, but that's actually not as good as it can be. The reason for this is that we are using a non-equality column as the first column in our multi-column index. In this case, age. And the rule that comes before the most selective column is that you should always have the equality predicate first.
Right, okay.
Yeah, so I'm going to go down, I'm going to drop that index I just created. Yep. And I'm going to create a second one when that's done. And this time I'm putting gender first. Yeah, and again.
Right, let me get that, that's right.
I'm going to put gender first and then age.
Alright, cool.
Yeah, so again, clustered index, just create that. Run through. So you can see here, back here we had, how many? We had 2,473 logical reads, which again is 8 kilobyte pages, and that's not a big number in this instance because it's not a very wide table, but if it was a really wide table that could be a big number, up your I/O quite a lot. So that's done. So I'm going to again just do the non-cheaty stuff, and then I'm going to run this again. And as you can see, logical reads has gone down quite significantly. Yeah, it's come down from, what was it, 2,473, it's come down to 1,297. So you've actually cut off like 800 pages by putting the, albeit a very unselected column, but the equality predicate first.
Awesome. Thank you very much, Dave. Cool. Good stuff. That's the sort of thing we like on SQLBits very much. Thank you.
Cheers.